For our last example on this page, we want to differentiate y is equal to e to the secant of 3 theta. So we're going to start just like the other ones by listing all of the functions in order from outermost to innermost in our composition. So first we have e to the theta, and we see that because we have secant of 3 theta, and that's the only other part of the function, but that's plugged into the exponent of e to the x. Second, we have secant of theta, and plugged into that, we have 3 theta. Okay, so now let's walk through the chain rule one step at a time. So we start by writing dy d theta just because those are our two variables. We have y as the y variable, we have theta as the x variable. So that's all that means. So let's begin by taking the derivative of that first layer, e to the theta. So we know the derivative of e to the x is just e to the exponent. So our exponent here is theta. But our exponent is actually secant of 3 theta. So that's the inner function. So we have e to the secant of 3 theta. And so let's highlight here where we're doing this. So we have this layer is getting taken care of by this function right here. Okay? In our next layer, we want to focus on this d theta of secant of 3 theta. Okay, so we keep that e to the secant of 3 theta the same, and we multiply by the derivative of secant, which is secant tangent, but inside of that function, I want to put that inner function, 3 theta. So I have secant of 3 theta, tangent of 3 theta. And so just to clarify, let's highlight where that middle layer is coming in. So that secant of theta comes in here, and we take the derivative of that right there. Finally, I want to look at my innermost layer, 3 theta, and all the stuff I did before just gets carried along down in the work. So we have e to the secant of 3 theta times secant of 3 theta, tangent of 3 theta, and finally I want to take the derivative of 3 theta. Well, 3 theta is just like if you had 3x, and if we were going to take the derivative of that, it's just a simple power rule, and we get 3. So let's highlight that innermost layer just so we're clear on where that comes from. So we have 3 theta appears here, and we end up taking the derivative of that right here. Come on, highlighter. Come on. Okay. I think the highlighter's loading. Let's give it a second and see. Okay, well, let's do this a different way then. So, see if the pen will work. So I'm going to box the 3 theta. There we go. So that comes in here, and then we take the derivative here. Okay, sorry the highlighter didn't work on that one. Hopefully it works later in the video. Okay, so far in these first 3 examples, we've looked at the chain rule 3 different ways, but it's only been applied to basic functions. So those are those functions in that big table in lesson 7. But now what we want to do is think about other rules we've learned, so maybe more complex power rules, product rule, quotient rule, and we want to combine that with the chain rule. So that's what we're going to do in the next example. We're going to combine the chain rule with the quotient rule. And so when the problems get more complicated like this, so we've been writing out like all the functions that are nested together, but it also helps a lot to think about what's going to be your strategy for doing the derivatives of those nested functions. Okay, so we kind of want to think about nesting the rules as well as nesting the functions, all kind of hodgepodge together, sort of. Okay, so let's look at this example. So we have find the derivative of g of t is equal to t minus 2 over 2t plus 1 all raised to the 9th power. Okay, so first of all, let's list the functions in this composition from outermost to innermost. So notice in this example, I haven't told you how many functions there are, so that's your job to figure out, but I can tell you it's going to be 2. So we kind of have, let's test the highlighter again. So we sort of have this exponent on the outside, and then we have this quotient on the inside, okay? So I'm going to write that as t to the 9th is my outside function, and t minus 2 over 2t plus 1 is the next thing in, and I think that's all we have here. Okay, so let's list the rules necessary for finding the derivative of each of these component functions. So for t to the 9th, we need a power rule. For that quotient, we're going to need a quotient rule. Okay, and let's keep up with our highlighting scheme, just so we're clear on where all this is coming from. Okay, so what this is going to tell us is once we've done the first step of the chain rule, where we've taken care of the t to the 9th, and now it's time to go find the derivative of the quotient, we're going to have to apply quotient rule in order to find that derivative. Okay, so this is where these problems get pretty complicated. Okay, so let's dive in. So we have g prime, so that's our derivative. G prime of t is going to be the derivative of t to the 9th. So we take t to the 9th as 9t to the 8th, but I want to plug in that pink function on the inside. So we have that quotient t minus 2 over 2t plus 1, and then I multiply by the derivative of the quotient. So this is the derivative of the yellow function, and then now I want to take care of the pink function. So remember, with that pink function, I'm going to need a quotient rule. Okay, I'm not going to sing the song for you again, but hopefully you remember that quotient rule is really easy to remember if you think about Snow White, the movie. Okay, so we want to do the bottom function, so low 2t plus 1, d high, so the derivative of t minus 2 is 1, minus high, so t minus 2, d low. So the derivative of 2t plus 1 is 2, and all of that is over low squared, so 2t plus 1 squared. So that's my quotient rule. And again, I'm just going to keep up the highlighting scheme. So this is the derivative of my pink function, as is that. So that's after we've actually taken the derivative. Okay, now I just want to help you practice simplifying a little bit. So remember, on this test, we're not too concerned with you guys simplifying. However, in future tests, you may have to solve an equation or something of that nature, which it would be useful there to simplify. So we're just going to practice here because it only takes a couple steps. Okay, so to simplify this, I'm going to really worry about that big quotient rule thing over there. So this first part I'm going to keep the same in this step, and I'm going to work on distributing the top of that fraction. So we have 2t plus 1 minus 2t plus 4 all over 2t plus 1 squared. Now the 2t's cancel out here, and so I end up with 5 on the top of the quotient rule fraction. So 5 times 9 is going to give me 45 times t minus 2 to the 8th. And then I have 8 copies of 2t plus 1 in here. And I have 2 more copies out here. So that gives me a total of 2t plus 1, 10 copies of 2t plus 1. So I have 2t plus 1 to the 10th. Okay, so that's an example of how you might simplify one of these. Remember, though, not necessary at this time. But practicing is always good. All right, so that's the lesson on the chain rule. Just remember to check your understanding before moving on to the pre-recitation prep and the homework.